My name is Marco Pereira. I do have a particular set of skills I have acquired over a very long career. Unfortunately, none of them are related to speaking. Me speak bad. My natural delivery doesn't make justice to my theory, so I am producing a better experience by using AI and a voice synthesizer. Welcome back to the Hypergeometrical Universe series. As you know by now, I developed the theory of everything, where the universe is represented as a light-speed expanding hyperspherical hypersurface. I learned how to model the universe by dissecting it into cross-sectional pieces. Here, you can see the circles representing our 3D hypersurface that is expanding at the speed of light. You can also observe the proper reference planes, x, tau, x prime, tau prime in space-time, right panel. And x, r, and x prime, r prime are in the 4D spatial manifold, left panel, where we actually exist. We don't live in space-time, we live in space. Space-time is just a conceptual tool, not reality. I've already demonstrated that Einstein was mistaken about several aspects, including time dilation, space-time, relativity, covariance, the equivalence of inertial reference frames, the twin paradox, and his equations. The light-speed expanding hyperspherical universe, LEHU, topology is consistent with Minkowski spacetime as the local homology. This means that if you zoom in closely, the circles become straight lines or linear segments. These segments represent hyperplanes traveling parallel at the speed of light in one direction. This is exactly what Minkowski spacetime describes. However, there is a fundamental error in relativity related to time dilation. Time dilation is loosely defined, as time itself is always tied to processes. Everything we know about time comes from observing processes, such as the cycle of day and night, our biological rhythms, and the operation of atomic clocks. Einstein didn't have an underlying process that applied universally. The hypergeometrical universe theory, HU, does. HU incorporates a model of matter where particles are polymers of a monomeric unit called the fundamental dilator, FD. The FD represents a coherence between stationary states of deformation of space. It's a soliton process, meaning energy doesn't dissipate. There are only two states, electron and proton. Everything in the universe ultimately decays into electrons and protons. Neutrinos also play a role in this model but are slightly more complex due to their different frequency, explaining why neutrinos are ghostly particles with a Fourier interaction that varies with distance. HU introduces an underlying process, the tunneling between states in the FD coherence. This tunneling generates metric waves, termed the dilaton field. These waves have extremely high frequencies, around 10 to the 24 Hz, resulting in very short periods. The constant wavelength, approximately 1.32 femtometer, aligns with the Compton wavelength of a hydrogen atom. Electromagnetic waves are, as expected, waves on the top of these very fine waves. This means that everything we ascribe to the dilaton field also applies to light. This well-defined process is used to measure the passage of time in HU. The universe experiences discrete steps, termed de Broglie steps, in homage to Louis de Broglie, who introduced the concept of matter waves. In HU, these steps are the result of the constant wavelength metric waves created by the tunneling of the FD. Time dilation in HU is understood as changes in the timing between these tunneling events. The FD undergoes an 8-state sequence, starting from an electron, transitioning to an antiproton, then to an anti-electron, and finally to a proton, before cycling back to an electron. This sequence defines the passage of time and the dynamics within the hypergeometrical universe. Using LEHU, the fundamental dilator and the quantum Lagrangian principle, I derived the laws of nature from first principles. The forces go to zero when the absolute velocity reaches the speed of light. This means that higher absolute velocity slows down dynamics, and that is equivalent to time dilation. In other words, time dilation is an artifact of using the incorrect, empirical, laws of nature that are ignorant of the absolute reference frame and absolute velocity. What happens to the astronaut who falls into a black hole? Hence, when the astronaut falls into a black hole, its body gets spaghettized, of course, but also freezes. It falls down to the surface of the black hole as a frozen spaghetti. Currently, general relativity tells you the ludicrous idea that the astronaut would see the end of times, because time would freeze for him. The reason that is said is the decoupling of time with processes, a failure in Einstein's work. The Big Pop cosmogenesis model. This figure illustrates the Big Pop cosmogenesis as proposed by the hypergeometrical universe theory, WHO. 1. Initial metric fluctuation. The universe began with an initial hyperspherical metric fluctuation, similar to the two's orbital with nodes. This fluctuation is driven by the Heisenberg principle and has a 421 light-second 4D radius. This fluctuation features dilation in the inner layers and contraction in the outer layers. This state is described as a 2S-like hyperspherical initial metric fluctuation. 2. Inner dilation layer and outermost contraction layer. After the initial fluctuation, partial recombination occurs, resulting in two remaining layers, the inner dilation layer, IDL, and the outermost contraction layer, OCL. The OCL represents our universe. 3. Blackholium formation. The IDL pushes the OCL outward, creating a state called blackholium. Blackholium is characterized by its hyperspherical shell shape, differing from the conventional spherical black holes. 4. Neutronium phase. As the universe expands, blackholium reaches the density of a neutron star, transitioning into neutronium. This phase marks the peak density of the universe during its early stages. 5. Neutronium decay and CMB creation. Continued expansion leads to the evaporation of neutronium. This process releases energy, causing the decay of neutronium into neutrons, which further decay into electrons, protons, and antineutrinos. The release of 0.78 MeV per neutron contributes to the heating of the universe, marking the first significant temperature increase from an initial 0 Kelvin, 0 entropy state. This phase also leads to the creation of the cosmic microwave background, CMB, representing the surface of the last scattering and establishing an absolute reference frame. Milestones of the expanding universe. 1. Blackholium-neutronium phase transition. As the universe expanded, the density of blackholium reached the peak density of a neutron star. This transition saw flat hydrogen transform into neutrons, acquiring an additional degree of freedom. 2. Neutronium acoustic oscillations, NAO. The transformation led to the release of 4D acoustic waves within the neutronium. These oscillations differ from the baryonic acoustic oscillations, which occurred later when neutronium began to evaporate. 3. Freezing of NAO. As the universe's density decreased, there was a sudden shift in the sound velocity within the neutronium. This change anchored the NAO in place, even as the universe continued its lightspeed expansion. 4. Evaporation of neutronium. The universe's ongoing expansion led to the evaporation of neutronium, releasing energy for the first time. This energy, amounting to 0.78 MeV per neutron, was initially released in low-density regions, resulting in high-frequency density fluctuations. 5. Cosmic microwave background, CMB, release. The universe's adiabatic cooling eventually brought its average temperature down to 3,443 Kelvin. At this juncture, the plasma recombined, releasing the CMB and marking the surface of the last scattering. This event corresponds to a distinct hypersurface, allowing us to measure our speed concerning it and consider it as an absolute reference frame. Just to reiterate, the Big Pop cosmogenesis, WHO proposes that the universe started with a simple Heisenberg principle-driven hyperspherical metric fluctuation of 421 light-second 4D radius. The universe starts from a Heisenberg principle-dictated metric fluctuation having contraction in the outer layers and dilation in the inner layers, which partially recombines. That is called the Big Pop. After the partial recombination, The remaining layers are the inner dilation layer and the outermost contraction layer, our universe. Dimensionality reduction by dynamic reference frame. To understand dimensionality reduction, consider the analogy of surfers riding circular waves in a pond. Despite the pond being a two-dimensional surface, the surfers cannot control their motion along the radial direction. They can only travel tangentially around the waves. This limitation makes them perceive their space as one-dimensional rather than two-dimensional. Hypergeometrical universe theory, HU, analogy. In the context of HU, the inner dilation layer, IDL, behaves similarly to the circular waves in the pond. The IDL pushes all particles in the universe, forming a 4D metric dilation wave. This wave, where the negative energy is located in our universe, causes particles to experience a reduced dimensionality. Just as surfers can only move tangentially on the pond's surface, particles are constrained by the 4D dilation wave, simplifying their reference frame. This analogy helps explain why particles in our universe perceive their motion as occurring within a reduced dimensionality. The 4D IDL constrains their movement, effectively reducing the complex 4D space to a simpler, lower-dimensional experience.
So what happens to the astronaut that falls into a black hole? You didn't see yet the derivation of the laws of nature. What happens when I derive the laws of nature? I realize that the forces between particles, between neutral particles or electrically charged particles, decays with velocity and goes to zero at speed of light. This means that the dynamics itself of particles stop at speed of light, and that's equivalent to freezing the the astronaut. So what happens to the astronaut is that time dilation is actually the weakening of forces when the absolute velocity reaches the speed of light. So the astronaut dies in a fiery death, but he dies frozen as an ice cube. Not cold, but frozen. So that's what happens. So never mind trying to go into a black hole to live forever. That's not a good idea. And so that's it. Thank you for coming to my video. Feel free to ask questions. Bye bye.